Hi, in this video I'll prove the quadratic formula. That means I'll solve this equation on the left by using completing the square. Let's go. First of all, a quick history lesson. Where these A, B, C's are coming from? They're coming from Descartes. Descartes said we can use A, B, C, the beginning of the alphabet for the coefficients, and X, Y, Z as the unknowns. In this case, we just have X. Okay. In completing the square, the first part is I get rid of this principal coefficient, that being coefficient of x squared. So I factor out A and write it like this. Divide the other terms by A. Okay, so in this case, if I divide both sides by A, I can get rid of it as a principal coefficient. Okay, that's what I have now. This will, of course, equal to 0. Okay, now I know the rest, I suppose. I'll divide this coefficient by 2 and then square it, right? Okay, I extract the coefficient, divide it by 2 and square it. Why? Because this is my secret ingredient. If you like, you can check out our previous videos. Okay, this is b squared over 4a squared. Now, if this the first two terms of this expression had this as an element, then it would be a perfect square. Okay, then let's do that. X squared plus bx over a. Now I add it and, of course, subtract it, right? Because I cannot change the equation. And this c over a comes here, equals 0. Okay, so I have my new equation. I will deal with this equation in order to solve it. So this part I know is the perfect square of x plus b over 2a squared. Notice that square root of this term is b over 2a. Okay, equals, now I move this part to the other side. This is minus, so it will become plus b squared over 4a squared minus, because this will go to the other side as minus, c over a. At this point, I can expand this fraction by 4a in order to make the denominators the same. So let's rewrite it. X plus b over 2a squared equals b squared minus, now when I multiply 4a by c, it becomes 4ac, and the denominator will be 4a squared. Great. Now at this point, I take square root of both sides in order to reach this x. But as you know, it's just like minus 2 squared makes 4 and 2 squared makes 4, right? I mean, when you have something like this, a squared equals 4, this a has two values. It can either be plus or minus. So the same is true in this case. You see, when you take square root of left side, it's x plus b over 2a equals, now this can either be plus or minus. Now I take square root of the numerator, and the square root of 4a squared is obviously 2a. Great. Now all I have to do is take this term to the other side. Let's do it. X equals minus b plus or minus square root of b squared minus 4ac divided by 2a. So here is my quadratic formula. Quadratic formula. It seems complicated, right? Well, people thought the same way. So instead of writing all these letters, they thought of something like, let's call this part as delta and write it as square root of delta over 2a. So b squared minus 4ac is called delta. This is just an abbreviation in order to make the equation seem simpler. You see, now this delta its relation with 0 has consequences. For example, if this delta is greater than 0, then this will have a real value, and since I added and subtracted, I'll have two distinct real roots. Well, let's write it down. If this one is greater than 0, I have two distinct real roots. Great. And if this delta equals 0, now, since it won't change anything, I'll have just one root, okay? Only one root. Or you can say it like two roots will be same, or they will equal to each other. Okay, and if this delta is less than 0, then this will become a complex number. So since there's a plus and a minus sign, there will be two complex roots, but no real solutions. Well, let's write it down. No real solutions. Two distinct complex roots. That's what I will get. Okay. So that's the quadratic formula. What can you do with it? This means whenever you see a quadratic equation, just by plugging in these coefficients, you can solve every one of them. You just need the coefficients. And this formula leads us to some very interesting consequences, like, say one of my roots is x and one of my roots is x2. Now this will be minus b, let's say plus square root of delta over 2a. This will be minus b minus square root of delta over 2. These are my two distinct roots. Okay, let's see what happens when you multiply them. Let's multiply them and find out what x1 times x2 is. These are the same terms. You add them and you subtract them and then you multiply them. Well, this is like x plus y times x minus y. Well, that equals to x squared minus y squared. This is the identity of difference of squares. So I can write it like, I'll square the first one, b squared minus delta over 4a squared. That's what I will get, right, when I multiply them. Okay, let's plug in delta. B squared minus b squared plus 4ac divided by 4a squared. Well, these cancel out each other. So it's now 4ac over 4a squared. Now these cancel out. And what I get is c over a. So when you multiply the roots of the expression, you get c over a. Nice remark. What's next? Let's see what happens when you add them. X plus x1 plus x2 equals, well, let's write them down. Minus b plus square root of delta and plus minus b minus square root of delta over 2a equals, these cancel out each other, minus 2b over 2a, these cancel out, and it's minus b over a. So now I have two formulas. First one, when you multiply them, it's c over a, and when you add them up, it's minus b over a. So these are the consequences of the quadratic formula, but it has many other consequences. In order to see them, you need to solve many questions. Okay, see you in the next video. Bye bye.